Astronomers are fond of saying that if a picture is worth 1,000 words, then a spectrum is worth 10,000 pictures. What we're trying to do is build a new spectrometer for a generation of telescopes that doesn't yet exist, named SuperFIRE. It is an instrument that doesn't take images of the sky or pretty pictures. Instead, it takes what amounts to a prism and puts it into the light path of the telescope so that it splays out the light that's coming from a star that would appear as a point on an image and instead turns it into a line. We can actually learn about its atomic physics, its chemical composition, what the distance is of an object from us. And this really opens up the whole universe to us. We can use these telescopes like time machines so that we can peer back into the earliest portions of the universe, which corresponds to when the universe was about 5 to 10% of its present age. We've already done a conceptual design study of SuperFIRE, and we believe that the basic building blocks are in place, that it should work. There's nothing that's standing in the way in a conceptual standpoint. What we're trying to do with the funding from the Kavli Foundation is take it to the next level of confidence. And at the end of the study that we're performing with the Kavli Foundation funds, we expect to know that we can build it, we expect to know how long it will take, and how much it will cost. Typically, when we go to build instruments like this, we apply to the National Science Foundation or NASA or other federal agencies to help us fund the construction costs. But before we can spend taxpayer dollars, we like to be absolutely sure that we understand every single one of those technical risks and that there's a clear and unobstructed path to a successful instrument build. But the size of the study tends to be in proportion to the size of the instrument that you're trying to build. And there comes a point when you try to build instruments that are much larger that the traditional ways that we have undertaken these studies, they don't really scale either. That you need a bigger team, you need more people, and there are more risks to be retired when you're doing something that's at the bleeding edge.